Hi, Assalamualaikum and a very good morning. So now we are in chapter 4, chemical bonding. And now we're going to look into the subtopic of 4.2 molecular shape and polarity, part 1 of the video. So in this video, we're going to learn about the explanation regarding the valence shell electron pair repulsion theory, or known as VSEPR. Also, we're going to learn about the drawing of the basic molecular shape, which includes linear, trigonal planar, tetrahedral, trigonal bipyramidal, as well as the octahedral. For the learning outcome of C, we're going to look about that in the next video, which is in part 2 of the video. For now, let us focus on the part 1 of the video first. So, molecular geometry and VSEPR. So, molecular geometry are basically telling you about the 3D arrangement of an atom in the molecule. Molecular geometry menerangkan cara atom disusun di dalam satu molekul secara 3 dimensi. And this basically describe of how atoms going to arrange themselves in reality. And by understanding the 3D arrangement, it can help us to understand about its physical as well as the chemical properties. And the molecular geometry can be determined using the VSEPR model, which is the valence shell electron pair repulsion theory. So according to the VSEPR theory, it was stated that the valence electron pair surrounding a central atom gonna repel one another, and the bonding pair and the lone pair electron will arrange themselves as far apart as possible in order to minimize the repulsion. And as what you know that the electron pair gonna consist of bonding pair as well as the lone pair. So you can imagine it to be like a structure of ammonia. So when you have ammonia molecule, which is NH3, and then when you draw the Lewis structure, you're going to get the structure to be N with one lone pair here, and then you're going to have the bonding pair to be something like this. Okay, so usually you will draw it in terms of like this, right? Okay, but in reality, the shapes that it's going to produce here is to be something like this, in which they are trying to minimize the repulsion between the lone pair with the bonding pair, with the bonding pair with another bonding pair, because electrons and electrons going to be repelled towards one another. So they are trying to minimize the repulsion. Okay, so this is the correct way of drawing the Lewis structure based on the VSEPR. So we're going to look into more example after this. And in the molecule, there are going to be 3 types of forces. So we have the between the bonding pair and bonding pair, BP and BP. And then next we have the lone pair with bonding pair, LP and BP. And we also have between the lone pair and the lone pair, LP and LP. And the repulsive force between the lone pair and lone pair gonna be the strongest in comparison to lone pair and bonding pair and the bonding pair and bonding pair. So this one gonna be the strongest. So the lone pair of electron repel more strongly than the bonding pair electron because the region in space occupied by the lone pair electron is smaller and it is closer to the atom. So you can imagine it to be like a structure of water, which water have 2 lone pairs, and then they're going to have a bonding pair between oxygen and hydrogen, which is like this. Okay, so when you compare the angle between the ammonia and the water molecule, you know that because it have 2 lone pair, it gonna repel more strongly, and hence it gonna push the bonding pair from both sides, and hence this angle here will appear to be smaller. Okay. Meanwhile, in this case for ammonia, it only have the lone pair and the bonding pair, so it will repel less strongly, and hence the angle between the hydrogen and the hydrogen bond here will be bigger in comparison to the water here. Okay, because of the lone pair repulsion in water. Now we're going to look into the basic molecular shapes, at least for the multiplication syllabus. So first we're going to have the linear, which has a class of AB2. And next we're going to have the trigonal planar, which has a class of EB3. Next, we're going to have the tetrahedral with a class of EB4. And next, we're going to have the trigonal bipyramidal with a class of EB5. B5. And then next, you're going to have the A octahedral with a class of AB6. So you can imagine it to be the central atom to be A, and then it is bonded with two terminal atoms B and B here. So for this case, it is known as linear. So the most basic one. Okay, and for the trigonal planar, in the previous subtopic, you're going to learn that you have learned that you can draw it anywhere. For example, you can put it here, here, and here. So you have three bonding pairs. But in this video and in this subtopic, you're going to learn that the correct structure of drawing the Lewis structure is need to be followed the VSEPR, in which we need to make sure that the electron is far apart from one another and make sure we minimize the repulsion. So we're going to have terminal atom B here, terminal atom B here, and then the terminal atom B here. So we're going to have 120 degree, 120 degree, and 120 degree instead of like this, which is like 90 degrees. So they are very close together. So this one is incorrect and this one is correct. Okay, so similarly goes through all the other basic molecular shape. And we're also going to see on how the bonding pair can also be changed into lone pair here. And we're going to see how the angle changes when there is a presence of lone pair. Okay, so we're going to look about that one by one. So now we're going to look into the linear first, which has a class of AB2. So the number of electron pair is going to be 2, in which 2 of them are bonding pair. So the electron pair here is basically equal to the number of the bonding pair plus lone pair. So because it has two bonded to the terminal atoms, so it's going to be 2 electron pair, and then the bonding pair, and in the class here, which is AB2, both of them are the bonding pair, and they're going to have 0 lone pair, which is something like this. Okay, so the bonding pair is represented by B. Meanwhile, the lone pair is represented by E. Okay, and as what you can see here, which is the linear AB2, the way that we can minimize the repulsion is by putting the two terminal atoms far away from one another. And as a result, you're going to have an angle of 180 degrees. You cannot put it like this because it's going to be very, very close together. And this is causing too much of the constraint. And according to VSEPR, we need to minimize the repulsion and we need to put it far away. So it needs to be 180 degrees. So you can draw it to be something like this, or you can also draw it to be something like this. And the type of repulsion that exists is only bonding pair with bonding pair repulsion. And the shape here is known as the linear. Selari sahaja. Okay. Now we're going to look into the next basic molecular shape, which is the trigonal planar, AB3. So you can imagine that you have a central atom, which is A, and then it is bonded with 3 terminal atoms. So the correct way of drawing that is we need to make sure that the terminal atoms far apart from one another. We cannot draw it to be something like this. Okay, because it is too close together. Okay, so in this case, which is the class of AB3, all of them is a bonding pair. So we're going to put it in this structure, and they're going to have an angle of 120 degrees. And the type of repulsion that exists between the bond and the other bond here is the bonding pair repulsion. Okay, and then the name of this molecular shape here is known as the trigonal planar. Seolah-olah dalam satu plane, dalam satu permukaan yang sama, they're gonna be 3 atoms. 1, 2, and 3. And you can imagine it to be something like a fidget spinner. Okay, so in this case, they're gonna be like a 3 terminal atom on a piece of paper dalam satu satah yang sama. Okay, And you can also change one of the bonding pair to be lone pair here. So when you change one of the bonding pair to be lone pair, then your class going to be changed from AB3 into AB2E. Okay, and the summation here is still equal to 3 electron pairs. Okay, but two of them are bonding pair, one of them are lone pair. So now when you change one of these to be lone pair, so you're gonna get the shape to be something like this. For example, A here, and then B here, and the B here. So the type of repulsion that gonna exist is lone pair, bonding pair repulsion, as well as bonding pair and bonding pair repulsion. And for this reason, they're gonna have a new molecular shape name, which is like a band, or you can call it as V shape. Okay, and the electron pair arrangement name is still maintained because they have 3 electron pair consistently. It's just that the number of lone pair and bonding pair are different. Now we're going to look into the next basic molecular shape, which is tetrahedral, AB4. So usually in the previous video, you have learned that A, and then you're going to have 4 bonding. You usually draw it this way. Okay, but in actuality, what's going to happen is that the central atom going to be bonded with terminal atom B in this manner. Okay, so what really happened was the central atom going to be here, and then B, B, and B here. So they're going to be like 3 of them are on the same plane dalam satu permukaan yang sama, and another atom here going to be B here, which is di depan plane tersebut, up front of the next plane. Okay, so you can also imagine it to be like this. So what's going to happen here is that in this case, the angle here is very constrained dalam 2D. Tapi dalam 3D, you know that the angle has widened up, okay, in order to minimize the repulsion. So you're going to have 109.5 degree. Similarly, go to here and to here and to there. Okay, and the class of this basic molecule going to be AB4. And as mentioned, you can also change one of the bonding pair into the lone pair. So from AB4, you're going to change it into AB3E. Okay, so example of the molecule is like the ammonia that I'm showing you just now, NH3. So you're going to have the structure to be something like this. Okay, so when we change one of the bonding pair into lone pair, so they're going to be a lone pair bonding pair repulsion. So what's going to happen here is that they're going to be a stronger repulsion, and as a result, it's going to push the bonding pair together, and hence the angle will get smaller and smaller. Okay, the repulsion between this one and this one is less strongly, but here and here is more strong, that it causes the angle to be smaller. Okay, seolah-olah telah ditolak angle tersebut dan menjadi lebih kecil di sini. Okay, and at the same time, you can also further change one of the bonding pair, for example here, and you change it into lone pair. So what you're going to get is to be something like this. Then B here, and then B here. Or you can also put it in terms of like this. Okay, where you change this side here and this side here, or this side and this side here, so that you can see one of them to be lone pair, up here to be lone pair, and here to be lone pair. And then because it's at the front and at the front, so you can put it like this. So it depends on the direction that you are seeing. So essentially, what you're gonna get is you're gonna get a new shape, which is band or V shape, almost similar to what you have learned in the previous slide, which is AB2E. Here is AB2E2, which shares the same name, but it has 2 bonding pair and 2 lone pair, which is under the class of AB4. here is under AB3 because one of them is lone pair. Okay, and as what you can see here, there's going to be a presence of lone pair and lone pair. So when there is a repulsion, so they're going to push the bonding pair and bonding pair more strongly, and as a result, you're going to get even smaller than the original 109.5. Okay. Next, we're going to look into the next basic molecular shape, which is the trigonal bipyramidal, AB5. So in 2D, you might expect it to look something like this. Like, for example, you want to put all the items in one side. But this is not ideal because it's very close together and the repulsion is very strong. So in 3D, what they're going to do is two of them going to be on the same line, and then the other three gonna be in different plane. Okay, salah satu permukaan adalah secara melintang, lagi satu permukaan adalah secara menegak. So it's gonna be like this and like this. So paper here and another paper here. So two of them on their vertical paper, and then three of them on the horizontal paper. Or you can imagine it to be like a triangle. So in every edges of the triangle, dekat setiap bucu ada satu atom, and atas dan bawah ada lagi satu. Then they're gonna be a central atom in the middle, A here. So this is how they're gonna minimize the repulsion, which is the correct way of drawing a AB5 here. Okay. And as mentioned, you can also change one of their bonding pair into lone pair. Okay, so one you can change anywhere that you like, but usually we're going to take at the, because you know this surface here, it have 3 electrons, right? So we're going to change either at this side, either at this side, or either at this side, doesn't matter. But for me, I will change it on this side. So when I change it into lone pair, what I'm going to get is to be something like this. So similar as the structure as shown here. And if I were to put it horizontally, okay, kalau sepusing dia secara melintang, what I'm gonna get is to be something like this, right? And it looks like a jongkang jongkit. And that is why the name here gonna be named as seesaw, or known as a distorted tetrahedral. And because it has a lone pair and bonding by repulsion, so the angle will get smaller and even smaller than the original one. Okay, but they are having the same electron pair, cuma bonding pair dan lone pair sahaja yang berubah. Okay, and of course you can also further reduce it into become AB3E2, yang mana mula-mula sekali 5 bonding pair, but now you change 2 menjadi lone pair. So it's going to be AB3E2, which is as shown here. So if you were to draw it like this, right, which is this one is the original one, and let's say the molecule have 2 lone pairs, and you can change it, the bonding pair and the bonding pair here, to be something like this. And as a result, what you're going to see is like a T shape here, seolah-olah macam bentuk T, and that is why the name going to be T shape. And now you have the lone pair and lone pair repulsion, lone pair bonding pair repulsion, and then you also have the bonding pair and bonding pair repulsion. Okay, and the angle now will get even smaller than before. Okay, and now let's say I'm going to change one of my bonding pair here into a lone pair again. So what I'm going to get at last is I'm going to get to be something like this. So it looks like a linear dalam satu garisan yang lurus. So you can also draw it to be something like this. And it's basically the same thing. Okay, and it has the angle of 180 degree because there's no bonding pair here. And as a result, the molecular shape here is known as linear, but the electron pair arrangement is still be named as trigonal bipyramidal because it has 5 electron pair, 5 electron pair, 5 electron pair, 5 electron pair, which is the name, the original name. But because of the presence of the lone pair, it's going to become linear according to its number here. Okay, now we're going to look into the last basic molecular shape, which is the octahedral AB6. So for the structure of AB6, the best way that we can arrange them is we're going to put 4 of them in a paper dalam satu permukaan ataupun dalam satu kertas yang sama, and then di atas kertas tersebut we're going to have the bonding pair, and below the paper we're going to have another atom. So if you were to look something like this, you're going to get the angle from one position to another to be 90 degree. So the best way is to look at here. So you have a 90 degree angle here, 90 degree angle here, 90 degree angle here, and 90 degree angle here. And from the upper to the bonding to the terminal atom here, the angle here will also be 90 degree. Okay, and at first, if all of them are bonding pair, the angle going to be 90 degree as well as 180 from the start to the below here. Okay, from up to bottom going to be 180, but from side to side going to be 90. And similarly, you can change one of the bonding pair to become lone pair. So once you do that, what you're gonna get is like a pyramid. B, 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 and then you have A at the center, right? Dalam satu kertas yang sama, and then you have another B at the top or at the bottom, doesn't matter, you can choose. And then what you're gonna get lastly is almost like a pyramid shape. And then it have a square base. Ada dasar yang petak ataupun ada permukaan bawah yang petak. And because of that reason, it's going to be named as square pyramidal. Tapak, kotak, dan dia membentuk piramid. Okay, and here we'll have the lone pair, and that is why the repulsion is going to have lone pair and bonding pair. And then you can also change another bonding pair here into lone pair again. So once you do that, what you're going to get is like lone pair on the top and lone pair at the below here. Sebab dia jadi AB4E2. 4 bonding pair, 1, 2, 3, 4, and 2 lone pair up and below. So it looks like a piece of paper which is square. And because of that reason, it is named as a square planar. Sebab dia dalam satu permukaan yang sama. And now you're going to have lone pair and lone pair repulsion, lone pair and bonding pair repulsion, as well as bonding pair and bonding pair. The bonding is still here, but then the lone pair is at the top and at the below part. So in this page here, it shows the summary of what we have learned so far. So on the left hand side here, it shows the number of electron pair. For example, electron pair number 4. So when it have 4 electron pair, we can have various shape. So the electron pair geometry is going to be tetrahedral. And when all the electron pair is bonding pair, it's going to be AB4, which is tetrahedral. And one of the bonding pair can be changed into lone pair, and it's going to become AB3E, which is the shape of trigonal pyramidal. And one of this bonding pair can further be changed to lone pair, so it's going to become AB2E2, and this will adopt the structure of band. So later you're going to see that there will going to be a molecule that will adopt this shape, another molecule will adopt this shape, and then will be another molecule that will adopt this shape. Okay, and they're going to have various angle because they're going to be different number of lone pairs that are present. And this slide here is very, very important because when you learn about the Lewis structure, you will need to be able to determine the correct shape based on the class the molecule having. So this slide here will help you in order to determine the shape that the molecule gonna adopt. All right. Now, let us look into the effect of the lone pair on the molecular geometry. As I mentioned, the CH4, NH3, and H2O are basically surrounded by 4 electron pairs. However, their bonds are different. Contoh ya, methane or metana, they're going to have 4 bonding pairs. However, for ammonia, it have 4 electron pair, but 3 of them are bonding pairs and 1 of them are lone pair. So it's going to become AB3E. For water, 2 of them are bonding pair and 2 of them are lone pair. So the shape of methane going to be looking something like this. So 4 bonding pair, CH4. But the shape of ammonia going to be H, 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 and then with 1 lone pair. And for the shape of water, they're going to be looking something like this, which is 2 bonding pair and 2 lone pair. And because of the presence of the lone pair, it's going to push the bonding pair much more strongly, and as a result, the angle will get smaller from the original shape of the tetrahedral, which is adopted by the CH4. So the original shape here is 109.5, but because of the presence of lone pair, it's going to get smaller, which is 107.3. And now you're going to further change one of the bonding pair into lone pair, which is adopted by the water molecule, OH here. So because of the presence of 2 lone pairs, and the repulsion are much more strongly, and thus they're going to repel the bonding pair from both sides, and hence make the angle even smaller, which is 104.5. Okay, so you can make like a table here. You say that CH4 will have 4 bonding pair, NH3 have 3 bonding pair, 1 lone pair, H2O have 2 bonding pair and 2 lone pair, and this happened due to the presence of the lone pair repulsion, which is stronger than the lone pair bonding pair, as well as the bonding pair repulsion. So here they're going to have bonding pair, here we're going to have bonding pair, as well as bonding pair and lone pair. Lone pair and bonding pair. Here they're going to have all the 3 repulsion, which is lone pair, bonding pair, and then bonding pair and bonding pair. But they're going to adopt the same basic shape. Pasal keempat-empatnya ada 4 electron pair. Cuma berbeza jenis lah. Sini 4 bonding pair, ini 3 dan 1, this one 2 dan 2. So tetrahedral, and tetrahedral. And the shape they're going to be carrying is the tetrahedral shape for methane, Trigonal Pyramidal for ammonia, and the bend shape or the V shape for the water molecule. And when they have all bonding pair, the angle going to be 109.5. When they have 1 lone pair, it's going to be 107.3. When they have 2 lone pair, it's going to be even smaller, which is 104.5. Okay, and I hope that you can see that from the basic shape, for example, AB4, it can be changed into AB3E, and it can also be AB2E2, depending on the molecules that we have. And because of the presence of lone pair, the angle going to be changes as well. And of course, they're going to have a different molecular shape. Okay, so I think that's all for today's video. See you again some other time. Bye.